Alright, we're going to start with the lesson, first lesson of the trig graphs, and the first one we're going to do is graphs of sine and cosine with amplitude and vertical shift. So you're probably aware, maybe aware that the sine and cosine graphs, basically the shape of it is like a wave, and we did the unit circle the previous unit, and they have a relationship, meaning that when we did the unit circle, it had its 4 quadrants. And then let me just focus on the sine graph. So for example, if you're studying the sine graph, we know the sine value in first quadrant goes from 0 to 1. This is the sine value, and then when we look at the sine wave is basically the first part of the sine wave, which is from 0 to pi by 2, is basically starts at 0 and goes up to 1. And then when we go from pi by 2 to pi, it goes from 1 to 0, and this is pi, it goes from 1 to 0. And basically one cycle, which is basically the wave that keeps repeating itself, is called as a period, or basically one cycle is basically the 4 quadrants. So this is first quadrant, this is quadrant 2, which basically goes from 1 to 0, and then quadrant 3 goes from 0 to -1, that's why it goes below the sea level, as you may call it, and then it goes back to 0. So that is the connection, that's why we studied the unit circle, and that is the connection between a sine graph and a cosine graph and a unit circle. So I just wanted you to see that. Now let's focus on writing learning how to create the parent sine graph. So graph of sine x. So one thing you should know, that for both sine and cosine graph, that we are learning the parent, one period is always from 0 to 2 pi. What does that mean? That means what I draw from 0 to 2 pi, the wave that I draw from 0 to pi will keep repeating itself. It's not just that it starts at 0, ends at 2 pi. It continues, but that is what we study, because that's the one that keeps repeating itself, and that's called as a period. And so we're going to basically study that one period. One period is from first point is 0, the last point is 2 pi, and then you find the midpoint between 0 and 2 pi. So the midpoint between 0 and 2 pi we all know is pi, and then this is the quarter wave point of the wave. So the quarter wave point is between the halfway point between 0 and pi, which is the quarter wave point, is midpoint is pi by 2, and the midpoint between pi and 2 pi is, it's like 1 and 2 is 1.5. 1.5 is nothing but 3 pi by 2. So these are your 5 x values on the x-axis. So first point and the last point, the end point, midpoint is pi, quarter wave point is pi by 2, and 3/4 of the point is 3 pi by 2. And it's a good habit to get into the it's a good idea to get into the habit of writing it as first point, last point, midpoint, quarter wave point, 3/4 of the point, because you'll see as we start doing transformation, we will start calculating it as first point, last point, midpoint, and so on and so forth. What about the y value? We know that if you look at the sine graph, sine value, sine goes from 0 to 1 and to negative. So my maximum values are from 1, and minimum is -1, maximum is 1. But how does the value travel? The value travels from, so the way you want to think about it is, the sine wave starts at the sea level. So it starts at 0. From 0 it goes up. So if you look at it as a wave at the sea level, it starts at the sea level. From the sea level it goes up. Once it rises to the maximum, it can only come down. So it comes back to 0, and then it goes below the sea level, and then it comes back to 0. So these are the points you want to remember. These are the points that you want to remember for the sine graph. That sine graph goes from 0 to 1 to 0 to -1 to 0. These are the points that you'll write. And now let's go ahead and put that on the y-axis. So the maximum value is 1, minimum value is -1, and at 0, x0, y is 0, and when x is pi by 2, y is 1, and then comes back to 0, and then goes to -1, and then goes to. So basically, if I join these points, that looks like a wave. And remember, it goes on both the directions. So there are multiple waves. We are starting, like I said, we are starting only one wave. So what is the domain and range of this? The domain remember I said it goes on forever, so it's all real numbers or this, and then range is minimum maximum, and period is nothing but one wavelength or one cycle that keeps repeating itself. Alright, so this is my parent sine graph. Next I'm going to be doing parent cosine graph. Parent cosine graph also has the same period. Because why are they all having the same period? Because one unit circle is from 0 to 2 pi, and the value changes accordingly. So it's same 0 to 2 pi with the halfway point, quarter way point, and 3/4 of the point. And what are the cosine values? Remember, going back to your unit circle, cosine, so remember sine starts from 0, goes to 1, but cosine starts at 1. Remember that? Starts at 1 and goes to 0. So cosine starts, so if you want to imagine it as a wave, cosine starts above the sea level, comes down, goes below the sea level, 0 and 1. Remember, 0 and 2 pi should always have the same value because you go around the whole unit circle. Alright, so if I draw this on my graph, it's 0 to 2 pi, to pi, to pi by 2, to 3 pi by 2. Again, my values are only from, but remember, my cosine graph starts at top of the sea level, comes back to sea level, goes down, comes back, and ends at the same point. So remember, 0 and 2 pi should always have the same point. So this is how my cosine graph looks like. Alright, so this is what you need to remember. It starts above the sea level and goes like that. And the domain is the same, right? Everybody can see. Range is also the same because minimum maximum value. And one wavelength is still from 0 to 2 pi. Okay? Now that we have done the parent sine and cosine, we'll look at some of the transformation. So I'm going to go to the next page. And this is similar to, we just have to write, I'm just going to fill in the blank for this, and we're going to skip this because we talked about the whole quadrant and that. We'll go below that. Parent graphs of sine and cosine have a period of 2 pi. So this is important, and I already spoke about this, that one period is 2 pi. It's the entire unit circle. If the graph must be extended in either direction, the curve will repeat itself, which is what I said. It'll keep going. The one wave will keep going. We're starting only one wave, but that wave is going to keep going. Alright? Okay, so we're going to go, like I said, I'm skipping this part, and we're going to go to looking at the transformation. So any sine graph and cosine graph, the parent is y equals to sine of x or cosine of x, but there can be different transformation. Let's see what these different transformations mean. If there is a negative sign in the front, just like in a quadratic, right? If you have a quadratic with a negative sign in the front, what do the different things mean? The negative sign in the front means it is a parabola that's upside down. Therefore, it is reflected over x-axis. A is the amplitude. A is the amplitude. So this number in the front is actually the height of the wave. It's a vertical stretch or compression. So that's the vertical amplitude. A is the vertical stretch or compression. And D is the vertical shift here. Vertical shift up or down. What is this? Remember, my vertex has moved 5 units up. It moves 2 units back, and we don't talk about that. So instead of D, we will write C. C is the horizontal shift. This 2, right? This 2 is the same, the number along with X is the same, correlates with this C. So C is nothing but the horizontal shift. Okay, so let's do a few of these transformations. So I'm going to go on to the problem number 1. So it says f of x equals to negative sine x. So let's fill in these first. So the amplitude is the a, that is, it's just 1, the height is just 1, 1. Reflection, there is, yes, so you're just going to write yes or no. The period, we haven't talked about how to change the period, so it's just going to be 2 pi right now. And the vertical shift is up or down. There's no plus or minus any number, so there is none. And domain and range we will get to after we do the graph. It's easier to read the domain and range after we read the graph. But let's go ahead and take a look at. So whenever you're graphing a sine and a cosine graph, the first thing you're going to do is to create your x and y tables with the 5 key points. So the 5 key points are always 0, the beginning point, the end point, the midway point, quarter-way point, and the 3/4 of the point. And the y values are basically, so I'm going to give you 2 y values. One is going to be the parent, and then I'm going to write the transformation to the y. The transformation to the y are the a and the d. So, and we'll talk about that. But let's first write down the parent y values for the sine. The parent y values for the sine is going to be, remember, sine starts at the sea level. So it starts at 0, goes up, comes down again, goes below the sea level, and finishes at 0. Okay, now I'm going to look at my equation given to me and see what is the transformation taking place to my y equals to sine x. The only thing is it is reflected, negative y. So the only thing is negative y. Okay, so there's no d. So normally a and the d are the one that affect the y, but there's no y here. There's no d here. There's no a also. There's only reflection. So you just do negative y. So 0, negative 1, because you're doing negative y is 0, because negative of 0 is just 0. This becomes positive 1 and this is 0. You don't need these values anymore. You just need this table. And let's see how we're going to graph this. We will basically draw from 0 to 2 pi. Midway point is pi. Quarter-way point is pi by 2. 3 pi by 2. And my max. So, and then I look at my values. Sorry, this is plus 1. It's still negative 1 to positive 1. So those are my only values I have. But it's going to move in a different direction. So what do I notice here? 0 is 0. Pi by 2 is negative 1. Normally pi by 2 would have, because it's reflected, my sine graph is reflected, so it goes down first, then comes back up, then goes up, because 3 by 2 is positive 1, then comes back. So my graph looks like this. So my graph looks like this. Alright. So this is my transformed graph, and my domain is your x values, right? It's going on forever. And my range is negative 1 to positive 1. This is negative 1. We okay? Alright. We'll do one more transformation, and hopefully by that time you'll get the hang of it. And the rest of it you can look at the key and see if that helps you. I'm going to do, hopefully everything in page 3 is pretty straightforward. I'm going to go to page 4 and pick at least one of these and see if we can do this. So I'm looking at 5, which doesn't mean you shouldn't do the others. You should practice the others, and you can use the key that I post and look at the answers for that, and hopefully you'll get the hang of it. But I want to do one more with you before you get to practice by yourself. Okay, so here my amplitude is 2, right? This is A and this is D. So we haven't learned how to do B and C, and we are not doing that in this section. This section only has amplitude change and vertical shift. So there's no change in the X so far. So amplitude is 2, reflection is no, period stays as 2 pi, there's no change in the period so far, vertical shift is 3 up, and we'll get to the domain and range in a minute. Let's go ahead and create our X and Y table. So because there's no change to the x values, it's going to be from 0 to 2 pi. Midpoint is pi, pi by 2, 3 pi by 2. And before I write my final y value, I will go ahead and write my parent y value, because this is the one that gets transformed with a and d. So because this is cosine, cosine starts at 1, starts at the top of the sea level, goes to 0. From when it comes down, it goes further down, and then 0 and 1. What is the formula that you will use to calculate the new y? So what's happened? So my parent function is cosine x, so you're multiplying that with 2, so it's 2y, right? Because 2 times cosine x plus 3. This is the key thing. So please make sure you understand how to write your y formula before you do your. So basically the a and the d affect your y. The a and the d affect your y. So a is multiplied and d is of course added. So what do? You take the y, and 2 times 1 plus 3 is 5. Okay? Then this is 3, because, and then this is 2 times -1 plus 3 is going to be 1, right? 2 times -1, -2, -2 plus 3 is 1. And then this is 3 again, this is 5 again. So just do the calculation. You're basically, this is your y, and you're doing 2y plus 3 for each one of them. So this is my new table. You don't need this value anymore. Now you're going to graph this. Your graph is going to be from 0 to 2 pi, pi, pi by 2, and 3 pi by 2. Okay, what's my maximum? So if I look at my x, I see that there's nothing on the negative. So my lowest value is 1, 2, I have 3, I have 4, I don't have 4, but I have 5. So I mark these points so that I'll be able to graph it. Now let me go ahead and graph it. 0 is 5, because this is cosine, so it starts above the sea level. Okay, one more thing I forgot to mention. This d is a vertical shift, right? That means my whole wave is moving 3 units up. Is that clear? The whole wave is moving 3 units up. That means my sea level itself has shifted. So no longer is this my sea level, this is my sea level, which means my wave will go above and below this sea level, and we'll see how it looks like. So 0 is 5, because it starts above the sea level. Then at pi by 2 it comes back to the sea level, because this is my sea level now. From the top it comes down and then goes below the sea level, goes to 1. Comes back to the sea level, then goes up again. So those are your points. So let me go ahead and join these. And that is how your new graph looks like. So if you think of this as a sea level, and my wave is going, and 2 is the amplitude, that means that's the height of the wave. From the sea level it goes 2 units up. From the sea level it goes 2 units down. So I hope you kind of get some kind of a clarity. And one more thing, when you practice for the others, this is the key for calculating your new y value. So y values is 2y plus 3. Alright, so my domain is basically always all real numbers, because it goes from one end to the other end. But my range is, my lowest value is 1, right? And my highest value is 5. Alright, everybody, we are good. Hopefully you got it. I just wanted to talk about one thing for 6 and 7. The previous page, they're all very similar. If you got this, the previous page you'll be able to do this. I just want to talk about this one. So do you notice in 6 that it's written as -2? So you want to minus 3 sin x. This is not the standard form. In the standard form of a trig function, the sine and the cosine is the first term. And this is actually your d. So they've kind of, instead of doing a plus d, they've written d plus a. Because addition, subtraction is commutative, you can move it around. So this should be rewritten as f of x equals sin x as the first term minus 2. This should be the equation that you are. So this is your a and this is your d. Alright, so that means when you're creating your x and y tables, your new y, what will your formula be? Negative 3y minus 2. Whatever you write for your parent values, it's going to be negative 3y minus 2. So like I said, this is the key. So please make sure you understand how this is negative 3y minus 2. And the same thing for 7. 7 is also, you need to rewrite it. Rewrite it as negative 3 cosine x plus 1, because there is a plus 1. 1 has a plus in the front. So it is negative 3 cosine x plus 1. Okay, so hopefully you can finish the ones that I haven't done by yourself and compare with the notes key that I have posted.